Hello, welcome to our channel. In this video, we will talk about discriminant of quadratic functions, and that will help us decide types of solutions quadratic equations can have. First, let's look at the formula for the solution of quadratic equation. If we have equation ax squared plus bx plus c equals 0, then we say the solution is given by this formula, x equals negative b plus or minus b squared minus 4ac divided by 2a. Negative b plus minus square root of b squared minus 4ac divided by 2a. Now we ask which part of this formula decides if the solution is real. We have negative b here, which is always real. We have 2a in the denominator, which is always real, as long as a is not 0. Now the problem is here at the square root. So this whole thing is real only if this b squared minus 4ac is not negative. Because if b squared minus 4ac is negative, then we are doing square root of a negative number. So from this formula, we can see that it is possible to get solutions that are imaginary numbers. So this part, b squared minus 4ac, we call that discriminant. B squared minus 4ac is discriminant. So that is the part that decides if we have one solution, two distinct real solutions, or complex conjugates as solutions. So whenever b squared minus 4ac is 0, in that case, all of that goes away. So we are left with negative b over 2a. So we have one real solution. Whenever b squared minus 4ac is positive, so this is some real number. Square root of b squared minus 4ac is some real number, then in that case we have negative b plus or minus that real number over 2a. So when we do plus, we get one solution, one real solution. When we do minus, we get another real solution. So in that case, we have two distinct real solutions. And whenever we have b squared minus 4ac negative, then we are taking the square root of a negative number. So in that case, we get an imaginary number over here. So the solutions are negative b plus or minus an imaginary number over 2a. So the solutions will be of form u plus vi and u minus vi. So these we call complex conjugates. U plus vi and u minus vi are conjugates of each other. So whenever b squared minus 4ac is negative, the solutions are of this form. Let's look at some examples now. So here is our first example, x squared plus 49 equal to 0. We want to decide what type of solutions this quadratic equation has. First, we decide the values of a, b, and c. So a is the coefficient of x squared, which is 1. B is the coefficient of x term, which we don't have over here, so b is 0. And c is the constant part, which is 49. So now we evaluate the discriminant, b squared minus 4ac. B squared minus 4ac equals b0. So we have 0 squared minus 4 times 1 times 49. So this is definitely a negative number because we have 0 minus some negative number. So we got the discriminant to be negative. So we are looking at this case. B squared minus 4ac is 0. So we have two complex solutions of the form u plus vi and u minus vi. Let's quickly graph this function and see what we mean by having two complex solutions. So up here is my graphing calculator, TI-84 plus. So let's go to y equals, and we want to graph x squared plus 49. X squared plus 49. So the solution to these equations are those x values where x squared plus 49 is 0, which means where the graph of x squared plus 49 crosses the x-axis. Let's hit enter here and then hit graph. Let's go to window. X mean and X max are probably fine. Let's go to Y mean and Y max. So Y mean, I'm going to set at like -1. And Y max, let's put that at like 100. Hit enter and again go to graph. So that is the graph of the function x squared plus 49. So if you look at the graph, this function doesn't cross the x-axis. So it's always above the y-axis. So this is the x-axis here. It never crosses the x-axis. That means there is no x value, no real x value, where x squared plus 49 is 0. So whenever we get complex solutions and no real solution, there is no x-intercept. Because when we have x-intercept, we have a real solution. Okay, so we are done with this example. Let's look at the next one now. So here we have 12x squared plus 6x equals 0. So again, we will first note down the values of a, b, and c. I'm going to do it up here. So a is the coefficient of x squared, which is 12. B is the coefficient of x, which is 6. And c is 0 in this case. The next step, we just calculate the discriminant b squared minus 4ac. So that will be b squared is 6 squared minus 4ac. 4 times 12 times 0. So this is simply 36, which is definitely positive. So we are in the second case over here. So we must have two distinct real solutions for this equation. So that means two distinct x-intercepts when you graph the function 12x squared plus 6x. So let's quickly confirm that. Again, go to y equals, and let's clear this graph, and we will enter 12x x squared 12x squared plus 6x plus 6x, and then hit graph. We probably need to adjust the window since we are going to have some x-intercepts in this case. We will try to have our graph around x-axis. So x mean, x max, they are fine. Let's put y mean to be -5 or -10, and y max to be 10. Hit enter and go to graph. Let's change the window a little bit more. So it's like we need to stretch x-axis. So let's do x mean to be -2 and 2. So let's see, that gives us better view. Let's also stretch the vertical axis so that we get to see the intercepts more clearly. So let's put y mean to be -2 and y max to be 2. All right, so here we see that we have two x-intercepts, two distinct x-intercepts. So this one and this one. Those are the solutions to this equation. It looks like this is somewhere around -1/2 and this is at 0. So those are two real distinct solutions to this equation. So let's look at the next example now. So in this case, we have x squared minus 3x equals 18. So the first step is to write it in the standard form. So that is add 18 to both sides. X squared minus 3x plus 18 equals 0. So once you have this, we need to identify a, b, and c. A over here is 1, the coefficient of x squared. B over here is -3, the coefficient of x. And c over here is 18. So we got a, b, c. Now we calculate the discriminant, b squared minus 4ac. So b squared is -3 squared, and 4ac is 4 times 1 times 28. -3 squared is definitely less than all that, 4 times 28. So this is negative. So we are in this case again. So we have two complex conjugate solutions of the form u plus vi and u minus vi, where u and v are two real numbers. Okay, let's look at the next example now. Here we have 4x squared equals 4x minus 9. Again, the first step is to write it in the standard form. 4x squared minus 4x plus 9 equals 0. Let's subtract 4x from both sides, add 9 to both sides. And now we can identify the values of a, b, and c. These are the coefficients. So a is 4, b is -4, and c is 9. So using that, we can calculate the discriminant b squared minus 4ac. I can do that here. So b squared minus 4ac is -4 squared minus 4 times 4 times 9. So b squared minus 4ac. And it looks like this will also come out to be a negative number. This is 16 minus 16 times 9 will definitely be negative. Or you can use your calculator and confirm that this will be some negative number. So we are in this case. Again, we have two complex solutions of the form u plus vi and u minus vi. This equation also has two complex solutions. So this is all we have in this video. Thank you for watching. See you in our next videos.